Lesson 2-5, Graph Proportional Relationships. In this lesson, we are going to learn to use a graph to determine whether two quantities are proportional. Take a look at the Explore It question and the graph that goes with it. The graph shows the time it takes JC to print t-shirts for her school's math club. A. Use the points on the graph to complete the table. Are the quantities proportional? Explain. Take the points from the graph and place them appropriately in the table, where the number of t-shirts are along the x-axis and the time in minutes is along the y-axis. Now look at the table. Are those shirts and minutes in a proportional relationship? Well, if you take each of those pairs of numbers and you find k, the unit rate, y over x for each of those, what do you end up with? In each case, you end up with a ratio of 5:1. So in this case, yes, it is a proportional relationship. Now look at part B. Start at the ordered pair 1, 5. As you move from one point to the next on the graph, how does the x-coordinate change? Well, from one point to the next, the x-coordinate changes by going up 1. So we went from 1 to 2 to 3 to 4. Now, take a look at the graph. How does the y-coordinate change? So as you move from point to point, what happens to the y-coordinate on the graph? Does it also increase? And if so, by how much? Well, the first ordered pair is at 1, 5, and then look at how it counts on the y-axis as you move from point to point. And the answer is the y-coordinate does increase, and it increases this time by 5. Okay, last, let's take a look at letter C. Write the points for 0 t-shirts and for 5 t-shirts as ordered pairs. Graph the points and draw a line that passes through all 6 points. So remember, the t-shirts is your x number, so the 0 will be the first digit in that ordered pair, as will the 5. Now we need to find the y-coordinate that matches them. Well, if there are 0 t-shirts, what is the time it takes to make them? And the answer is 0. No t-shirts will take no minutes to make. What about 5 t-shirts? How long will it take for them to make 5 t-shirts using that unit rate? If you said 25 minutes, you would be correct. Now we're going to take those two ordered pairs and place them on the graph. So the point at 0, 0 goes right there. I put that in red. And the point at 5, 25 is up here also in red. And then we connect those points, and I'm going to use a blue line to connect them, to show the line that goes through all 6 points. Sorry, my line's a little bit sloppy, but this writing utensil doesn't draw straight lines for me very well. So the ordered pairs are at 0, 0 and 5, 25. Now let's take a look at example 1. The essential question for this lesson says, what does the graph of a proportional relationship look like? Example 1, graph to recognize a proportional relationship. Tanya exercised for 30 minutes. She noted the calories burned at 3 times during her workout. How can Tanya use this information to find how many calories she burned after 15 minutes of exercise? The picture provides us with the information we need in order to make a graph. We know that at 10 minutes, she had burned 95 calories. After 20 minutes, she burned 190 calories. And after 30 minutes, she burned 285 calories. We can use a graph to display the data. In this case, the X value is the time in minutes. So we're looking at the interval 10 minutes, 20 minutes, and 30 minutes. And after 10 minutes, it says she burned 95 calories. After 20 minutes, she burned 190 calories. And after 30 minutes, she burned 285 calories. Now let's take a look at the relationship between the exercise time and the calories burned to make sure it's proportional. The ratios that we've got on the graph there could be written as 95 over 10, because remember this is a y to x relationship. That's how we know if it's proportional. We also have a 190 calories after 20 minutes, and we have 285 calories out of 30 minutes. So what are the unit rates for each of those? In other words, how many calories is she burning each minute that she exercises? In all three instances, the calories burned is 9 5/10 for every minute that she exercises. This is a proportional relationship because in this problem, our K value, which remember is also called our unit rate, can be found by doing that division. So our K value here is 9 5/10. Now we can use the graph to find that constant of proportionality. So I'm going to move my paper up a little bit there. There we go. And in step 2, we're going to either use the graph or we can use the equation. All right, so their step 2 says to use the graph to find that constant of proportionality. In other words, they're looking at the differences between the coordinates of any two pairs. In other words, how far do you have to go over? In this case, going across on the x-axis is the blue. And then how far do you have to go up? And in this case, that is the red. So we go over 10 each time. And then we go up 95. So for every 10 minutes of time that she is working out, 10, 20, and 30, she's increasing her calories by 95. Okay? That constant of proportionality tells us that we have a K value of 9 5/10. So the constant of proportionality can help us determine how many calories she would burn in 15 minutes. This also allows us to use the equation y equals kx. Remember that y are the number of calories and x are the time in minutes. So if we know that she's going to be working out for 15 minutes and we know the k value, which is 9.5, we can use those to solve the problem. The number of calories burned, y, equals k, the unit rate, which is 9 5/10, times the number of minutes, x, that she is working out. And 9 5/10 times 15 is 142 5/10 calories. Now take a look at the try it question. Each 1/4 cup serving of cereal has 3 grams of protein. How can you use the graph at the right to determine whether the quantities are proportional and to find how many grams of protein are in 1 cup of the cereal? Well, if there are 3 grams of protein, that's your Y number. For every 1/4 cup of cereal, that's your X number, then we can use the ratio Y to X to figure out how many grams of protein are in 1 cup. We can also use the graph to help us. So as I go over here to the graph, I'm going to put the ordered pair for the Y and the X number. Okay, in this case, the X is the 1/4 and the Y is the 3. And we're going to place that ordered pair on the graph right there. So the question now is, well, what if I have half of a cup of cereal, which is twice as much as a fourth of a cup? Well, if I have half of a cup, I should have 6 grams of protein. If I have another fourth of a cup added on to that, so 3/4 of a cup altogether, I should have 9 grams of protein. So the question is, how many grams of protein are in 1 cup of cereal? Well, use the unit rate. 3 divided by 1/4 means that we're going to multiply both parts by 4. And you get 12 grams of protein in 1 cup of cereal. This is a proportional relationship. Now look at the red line that goes through those 3 points on the graph. The red line shows a picture of what that proportional relationship looks like. Now before we go on to the convince me, I would like for you to go back up here and look at the top of your page. There is one piece of information up here that we didn't highlight and we really need to pay attention to, because this actually is the definition of a proportional relationship on a graph. Anytime you see a graph, and I'm going to highlight this whole thing, that has a straight line that passes through the origin, okay, the origin is that point 0, 0 here, okay, the origin is 0, 0, and it's a straight line through that point, this is when you have a proportional relationship. Those two conditions must be met for the relationship to be proportional. And last but not least, let's take a look at the convince me down at the bottom of the page. So I'm going to make my paper bigger here. There you go. Make it a little bit more visible. And the convince me asks, how can you find the constant of proportionality, this, from the coordinates of one point on the graph? Well, the point that you're looking for here is the point that gives us the unit rate. And remember, the unit rate is the amount out of 1. In other words, the unit rate is when the x number equals 1 whole. So in our ordered pair, we need to look for that has a 1 in place of the x, and then we're looking for the y number. That constant of proportionality is going to tell us what is that y number in the ordered pair. Now let's try some practice questions in examples 2 and 3.